A piece-based model isn't much more than a model with a bunch of pieces, unless you can use it to illustrate a sequence or a process in construction. In fact, this ability to simulate phases, operations, placement, and generally coordinate construction is the kind of information that makes a construction model useful. The purpose of this video is therefore not to demonstrate how to put pieces together, but to show how to set up the model as an operating environment. First, all design drawings using beams and columns for the general building construction have column line designators. These are addresses that are referenced during coordination of the drawings between consultants. It's also useful for moving and assigning work in the field, where a contractor can position people according to column lines. Go to floor 2 between column lines 3 and 4 along column line A. These are therefore addresses used between subcontractors, equipment operators, and the design team. Important as they include vertical floor line dimensions as well as horizontal grid, which maps things in 3 dimensions within the building structure. These are then the same addresses used to move things around in the virtual environment. For the crane, the column labels are displaced to be closer to the boom and act as guides or a reference for rotating and placing the hoist. And the vertical floor markers extend the grid to raise and lower the hook. In addition, the arc of crane movement can be mapped over the grid with compass points. The arc also references the distance along the boom for pickup and placement in staging and assembly areas. These areas are designated pickup points or shakeout areas, control zones, and assembly areas. Like a crane operator, you can set control markers to return to these spots over and over again. Crane operators must be aware of these distances because of load limitations. And the control zones restrict operation of the crane, limiting its movement. For example, swinging a steel member across the zone would be dangerous for the management structures that are in this area, the job trailer, vehicles, other storage. On large projects, the laydown areas will also have grids. These designate the location of materials waiting for installation. On this building, column and beam placement is fairly straightforward. The advantage of an information model is that crane movement and placement can be simulated. In addition, screenshots can be taken of steel flying into position. These kinds of simulations are especially important for tricky or complex lifts. For example, note the interwoven pattern of placement of columns and beams for the first floor of this building. Most ironworks would freak out at the idea of going up and down the steel to set first columns and then beams. They would want to set all of the columns at one time. The idea here is to establish a supporting core first. This stabilizes the wall and the center of the steel. Note that the beams and the columns are labeled according to the sequence of their erection. For example, this is column number 1 erection in the erection sequence. It's over here. Column 1 for floor 2. This is column C2. In other words, its address is C and 2. So its component name is steel 2, and its instant name is according to its erection sequence. Of course, in the field, these are labeled just much simpler, 1, 2, 3, 4, to minimize confusion. Information is held on a separate drawing. Most of the times, the erection plan in the shakeout area is just a scribbled piece of paper taped to some tree. The erection of steel on the 3rd floor, or the 2nd level of steel, is a lot more straightforward. This follows the traditional practice of all columns up and then all beams. But note that the columns have a pattern of erection. First we go along the back wall on the 0 lot line, then this outer wall, and then the interior columns. The beams are also placed in a way that makes it easy to lift them from the shakeout area. Since the iron workers are placing just beams, they can stay in the upper levels of the steel structure, moving out the core, then off to the perimeters in both directions. The advantage then of a construction model and the ability to manipulate the pieces in a virtual environment is that it gives you the opportunity to set up simulations like these. You can capture dramatic shots or more dramatic shots in order to gain attention and really begin to understand the sequences and the processes associated with any particular construction project.